Number 16. A simple pendulum is moved from Earth to the moon. How does it change the period of oscillations? Acceleration, they give you the acceleration due to gravity on the moon is 1.6 meters per second squared. So 1.6 meters per second squared is actually 1/6 g on Earth. So they want to know about the effect on the period. So period equals 2 pi square root. With a pendulum, it's L over G. So in this case, when we move it to the moon, G is actually going to be 1/6. So when we have 1/6 in the denominator, it actually becomes 6 in the numerator. The 2 pi doesn't change. The L doesn't change. The G doesn't change. The only thing that's changing is the 1/6 in the denominator. So we literally have 1 over 1/6, which will equal 6 over 1. So the period is going to be increased by the square root of 6. Number 17. The length of a simple pendulum oscillating with a period t is quadrupled. So we're quadrupling the length. What's the new period? So again, the period equation is period equals 2 pi square root L over G. And the only change that is happening here is that the length is being quadrupled. So the equation will be period equals square root 4 over 1, or 2 times the period. Number 18, a simple pendulum has a period of 1 second. What's the length of the string? So we'll use period equals 2 pi square root L over G. And to get L by itself, remember when we're undoing equations, we have to use PEMDAS in reverse. So is there subtraction here? No. Is there addition here? No. Is there division? No. Is there multiplication? Ding, ding, we have a winner. So we have to undo the multiplication by dividing both sides by 2 pi. So that would give us period over 2 pi equals square root L over G. Now to get rid of the radical sign, we'd square both sides, t over 2 pi. We do need to square that whole thing, equals L over G. And we're solving for the length of the string. So multiply both sides by G, we're going to get L equals T over 2 pi, quantity squared, times G. Now let's go ahead and square everything in the parentheses. We're going to get period squared over 4 pi squared times G. So pi squared is actually 9.8. So it would cancel with G in the numerator. So we're left with T squared over 4. The period they gave us was 1. So 1 squared over 4 is actually 1/4. The answer is E. Number 19. A simple pendulum with a length of 1 meter oscillates on the surface of a hypothetical planet X. What is the surface gravity on the planet if the period of oscillation is 4 seconds? So surface gravity, they're actually looking for G on planet X. We know what G is on Earth, but we want to know what it is on X. So we can use, since it's a pendulum, we can say period equals 2 pi times the square root L over G. And we want to isolate for G, because this is going to be G of planet X. So like we did before, we can divide both sides by 2 pi. And then square it. And that's going to equal L over G. But in this case, what we'll do is swap these two to get G by itself. And we're going to have G equals L over, and we'll go ahead and pause this. We'll go ahead and square everything in here. So we'll have t squared over 4 pi squared. All right, so since we have t squared over 4 pi squared, we have a fraction in the denominator. We will invert this fraction, and we're going to get L times 4 pi squared over t squared. All right, now we can go ahead and plug in our values. G equals, our length is 1 meter times 4 times pi squared, which we said pi squared is 9.8, over t squared. Our period squared is 4 squared. When you do that, you get a value of 2.45 meters per second squared, which is very close to D.